All right. Thank you everyone for joining. If you are seeing this, that means you are watching us live. So you have the fortunate opportunity to be able to ask us questions directly within the chat. As I go through today, I'm going to go and stop through and answer any questions that are relevant through the presentation and hopefully provide some clarity and help you learn. I'm really excited to have you all here and I'm ready to just jump into it. So as I get started, leave a comment in the chat there and let us know where you're joining from, what school you're from, and what you're excited for in this season of NCL. So let's get started. I'm Franz Pear with Cyber Skyline, and today we're going to dive into how you can use IP tables to secure your Linux machines. We're going to review what it can and cannot do, and go over a couple of common mistakes that you're going to want to avoid to prevent locking yourself out of your own systems. So this is going to be a fun episode. Thanks to you all for joining. So let's start first with what is IP tables. IP tables is a command line firewall program for Linux. It's probably going to be the go-to that you'll use. There are a lot of additional programs that will work on top of IP tables that will provide another interface for you to use when wanting to interact with your firewall. But I always use IP tables as a really good starting point. It gives you the most control over what you want to be doing. And it's a really powerful tool. I say it's a firewall, but it can do a little bit more than just generic firewall things. It can also be used to do things like port redirection. So if you want to send data from one interface to another interface and maybe swap what port it comes from and goes to, you can do that with IP tables. And you can actually use IP tables to effectively turn your device into a router with that functionality. So it is pretty comprehensive. We're not going to cover all of those fancy possibilities today. We're just going to be talking about using it for accepting or rejecting traffic. But as we dive into that, I want people to know a couple things about firewalls. Firewalls are not this magical thing that solves all of your cybersecurity problems. I think a lot of marketing with firewalls really makes it sound like it's like really, really important and going to solve everything, and you have to use a firewall, you're going to get compromised. That's not actually true. Firewalls are a very useful tool, but you need to use them in the right way. So some things to consider. All that firewalls are going to do is just block or accept connections. That's it. It isn't some magic elixir that's going to prevent you from getting breached. If you are running a web service and that web service is running on port 80 and you have a firewall rule that allows connections to port 80 because you're running a web service, if there's a vulnerability in that web service, the firewall is not going to do anything to prevent you from getting compromised. If a hacker is going to send an exploit and get remote code execution on your server, that's still going to happen regardless of the firewall. Because in order for your system to be functional, you actually have to allow those web connections. Otherwise, you're not even running a server anymore. So just keep that in mind, that all we're doing is saying what is and is not allowed to come into the system at this port, protocol level. We are not doing anything to inherently secure whatever software might be running on our machine. We could have a very insecure service running on our machine and it will still get compromised if we allow that connection from the internet. So just keep that in mind. Now, that being said, firewalls are very important. The reason why you might want to use a firewall is, say that you actually do have a web server and it should only be accepting connections from, let's just say, port 80 and port 443. It shouldn't be accepting connections from any other ports. By telling your firewall to only accept connections from those two ports, you can prevent a situation where maybe someone comes onto that server at some point in time and they install a new service that they're not supposed to. Well, the firewall rules would prevent connections into that new service, assuming that's running on a different port. So it's very helpful for this type of maintenance. On a consumer level, having a firewall means that if you accidentally download some malware and the malware is trying to listen on to a port to receive a connection from an adversary, a firewall rule could prevent that adversary from directly connecting to your device because the port is blocked. So there are some benefits there. It can also do things like prevent any new outgoing connections. So let's just say that you are running a web server and all it's supposed to be doing is taking in new connections from people wanting to connect to your website, and it should never be connecting outwards into the internet. There should be no reason for this web server to establish a new connection with someone else on the internet. Well, then you can block all of those. You can block all of those connections using IP tables. And if someone were to compromise your web server, they would not be able to establish a new external connection, connecting your server to an adversary. There's a lot of good functionality in here, just realize the limitations. So let's go over quickly how it works. I'm going to do highlights here because there's a lot to dive into with IP tables, and so these are just going to be the very basics. I'd say the three main chains that you would want to know for IP tables: the input chain, the forward chain, and the output chain. What these chains are basically just list of rules that get processed in order whenever there's a packet that is being sent through your device. And so this input chain is handling any packets that are coming into the device. The forward chain is anything, after it's come in, then it will look at any of the forwarding rules to see if there's anything there it should process. And then if there's any packets going out, that would be where the output chain comes into place. You will basically create different rules and they will sit on one of these chains. The order of precedence is very important because these chains have an order in which they're being processed, and any rules within the chain also have a specific order. And so you could have two conflicting rules. You could have one rule that says block all connections on port 80, and you can have another rule that says accept all connections on port 80. The order of those two things matters. If you have the rule for accepting all the connections, then it'll go through, no problem, and the block will not happen. If you have the block coming first and then the accept, well, then it never goes through. And so you have to be careful about the order of these things. And actually, now that I'm saying it, someone should double check me and verify if a connection is accepted, does it still see if it gets rejected somewhat later? It might actually be the case that if you have the accept first and then the reject might kick it out still. But I definitely know that if you put the reject first, that accept will never get executed. So the order really matters. You've got three primary actions: accept, drop, and reject. So accept just means the connection is good, continue going. So we're going to allow that traffic. Drop means that the packet will come in and we just will not do anything with it. So if someone is trying to connect to me on port 80, I am dropping traffic on port 80, I get the packet and I don't do anything with it. That's a little bit different than reject, because what reject will do is it will actually respond and it will say, hey, I'm not responding to you. But the difference here is that it's actually saying that it's the no comment, right? It's the no connect, like I'm not responding to you, but I'm telling you that I'm not responding to you. So the difference between these two is actually whether or not a response gets sent back to that packet, letting the other side know that their connection was rejected. And there are different reasons why you would want to use drop or reject. Drop is very nice if you just don't even want to let people know that there might even be a service listening. So something I've seen happen is you might have drops if you don't want anyone to try to connect to that service, and you might have a reject if, say, for example, you only want to allow connections from certain IP addresses. You might accept from those IP addresses and everywhere else you reject. And so that would be an indication that there is a service there, but you are just not being allowed to connect to it. You can see that there is an HTTP server that's just not responding to you. So hopefully that makes it a little bit easier for you. I see people in the chat saying that reject is kind of like being polite and not ghosting people. It's exactly the way that I would put it. Generally, from a security perspective, unfortunately, you do want to ghost people a little bit. You don't want them to know exactly what you might be running. Or you could just mess with them. You could just do rejects on every single port and make people think that you're running a service on every single port and you don't even know what's actually there or not. Those are different options, but keep in mind that these can be abused. Maybe someone is trying to DDoS you, and if you do a reject rather than a drop, well, that is more workload on your computer, on your device, because now instead of just ignoring them, you are sending data back to them, and that's work that needs to be done, and that's bandwidth that you're taking up on your own end. And so generally people end up dropping packets rather than rejecting them. All right, that's enough of that. Let's go over how you actually use it. So I've just got these 6 very, very common actions that you'll want to perform, and then I'm going to dive into a demo to show you how to do this live. The first one here is iptables-L. This lists all the rules on a chain. If you do not specify which chain you want, it's going to show you all the rules for all the chains. The next one here, append new rule. This is iptables-A. Then you specify which chain you want to add a rule to, and then all your subsequent arguments. So what IP addresses you want to be matching on, what ports you want to be matching on, what you actually want to do, what the actual action is going to be. Those are the arguments there. Now, the next one is prepend. So append means add to the end of the list, and prepend means add to the beginning of the list. And this is where I was saying that the order really matters here. And so being able to specify, hey, add it to the beginning, add it to the end is very important. I believe with prepend, you also have the option to specifically indicate where you would like to insert that line. So you don't necessarily have to insert it at the very beginning. You can put it arbitrarily, like, hey, I want to put this as rule number 3. You can do that as well. The next one here is delete a rule. That's iptables-D. When you do that, there's 2 options for how you delete the rule. One is you actually provide the number. So rule number 4, delete rule number 4. Or you can actually take the entire description of the rule. Let's just say port 80 drop. You can actually specify the entirety of that and drop the rule by describing the rule. The next one is to delete all rules on a chain. That's iptables-F. Be very, very careful with this one in particular. So this will delete all of your rules, but some of those rules might be required for your system to work. So if you have a default policy, which is reject all connections, and you have a rule there that says, hey, accept all of my SSH connections so I can remotely admin my machine. If you flush your chain but you did not update your default policy, if the way that you're updating this is not locally, but through an SSH connection, you'll actually kill your own SSH connection and you'll lock yourself out of your machine. So you got to be really careful about that. Be very cognizant when you're running -F. I have personally made this mistake before. I've seen a lot of other people make this mistake before. I feel like it's a rite of passage with using IP tables. It's going to happen to you. Just be aware that it might happen, and be cognizant of it. The fortunate thing about IP tables, if you are just modifying IP tables directly in this way, by default, it will not be retained through a reboot. And so if you physically have access to the machine, just give it a little bit of a reboot and it should go back to allowing everything and you should be okay, assuming you didn't do anything to save those settings on reboot. And the last item here is to set the default policy on a chain. So I mentioned, hey, if you have a default policy of reject, and then you have a rule there for allowing SSH traffic, and you are remotely administering your device through SSH and setting these IP tables through SSH, you might want to make sure that you've got the right policy set. So iptables-P will allow you to specify the default policy, accept, reject, or drop. And what that means is when iptables is looking at a packet, it will go through all of the rules, and if none of them match, it goes to the default. So I'm seeing a couple questions in the chat. We've got Rachel asking, does iptables deny by default? And the answer is no. iptables does not deny by default. When you have IP tables installed, the very default is just accept everything. So you're safe in that clean default configuration, but if you make any changes, no guarantees there. So let's actually go and try this out. Let's have a little bit of a demo. I'm shifting over here to my Kali machine, and what I have on the left panel is a Docker image of a Debian machine that has IP tables installed. And I'm going to show you what we've got here with our defaults and try to run through a couple of scenarios. So the very first thing I'm going to do is run netstat. If you're not familiar, netstat will display all of the ports that are and their statuses on your machine. And I always remember this as netstat-plant. For the life of me, I could not remember exactly what each individual flag does, but I know that when you run netstat with plant, you're going to get all the TCP ports that you want. So if I do netstat-plant, what you can see here is that I've got a service. We've got 3 entries here for TCP connections and 2 entries. So TCP on IPv4 and then 2 for TCP on IPv6. It looks like we are running something on port 111. I have no clue what that is. It doesn't give us a program ID or program name. Probably something that was installed and is running by default with my Docker configuration that I have here. And you can see that we're running an SSH server on port 22. SSH is the secure shell protocol and allows us to remotely connect to the command line and administer this device. We can also see that we've got something running on localhost, so it's not exposed to the world. Localhost on port 37289. Again, no clue what that is because we're not getting a process ID or program name. If I run it again, maybe it's gone. Nah, it's still there. So we're not sure exactly what that is, but that's not relevant for what we need to do today. What is important is the fact that you can see that there is an SSH server that is running on port 22. And if I run service status SSH, or service SSH status, we can see that SSH is running. Fun fact, I mentioned netstat-plant. If you want to get UDP instead of TCP, it's planu with a U instead of a T. Yeah, I guess T for TCP, U for UDP. So that's an easy way to remember it. So what I am going to do right now is I'm going to start up an HTTP server and try to connect to that HTTP server through my web browser and see that it's working. And then what I'm going to do is I'm going to block all traffic to that HTTP server and show you that we can use IP tables to block that traffic. So if I go over here, I am going to do this quick little hack, which is if you've got Python installed on your machine, there is a module that lets you run a basic HTTP server, and you don't actually have to write any code or install anything fancy. It just comes default in Python. I am going to actually run this in tmux, so I can run this server and kind of like hide it and go and do something else. Then of course, I cannot disconnect from my session. All right. Cool. I think my VMware is capturing my keystrokes, so I can't disconnect from my session. But what I'm going to do instead is just, I'm just going to background this then. All right. So we're backgrounding our web server, and I'm just going to go and pop open Firefox. Now we got to figure out where we need to connect. So to get my IP address, what I'm going to do is type in ifconfig. That will pull up the information on my interfaces. I'm going to do ifconfig eth0 because I know that is the interface for my internet connection here. And that looks like my IP address. And if I put that here in Firefox, I will have discovered that I need to probably take a look at my IP table settings because I might have already had some defaults. Yeah, I already did some defaults. So I'm just going to wipe this. I'm going to wipe this Docker image and start again. All right, so we're going to run our HTTP server like that. I'm going to background it using Control-Z. And then I'm going to check my plant and look at all these additional connections here because I opened up Firefox. But I can see here I've got my server on port 80. And then I am going to also do service start SSH. Service SSH start. And then we're going to check on our open ports again. And we've got Python running on port 80. That's our web server. And SSHD running on port 22. All right. Now let's check our IP table rules. So I'm going to do iptables-L. If I don't specify the chain, I'm going to get everything. So I'm just going to hit -L, and you're going to see a lot of entries in there that Docker put in. So we've got these like Docker user, Docker isolation. We're going to ignore all of that. What we care about is the input chain right now. And we can see that we've got an input chain here. Apparently did not get reset. So I'm going to do a -F on input, and I need to change my default policy. Accept. All right. So now if we look at our IP tables, the input chain, default policy accept, there are no rules. Let's just go and look at the output. Same thing as well. No rules. Default policy is to accept. All right. I think we're all set to get started now. So we've got our HTTP server up and running over here. I can go and navigate around here and look through my file system. So clearly we have we have our firewall settings allowing these connections. I'm going to do a quick Nmap scan and just verify what we can see in terms of open ports. So if I do Nmap on this IP address, 192.168.29.129. And I don't want to be here forever, so I'm just going to do ports 1 through 100. We can see port 22 open and port 80 open. All right, now let's block this connection. So I'm going to background this, and I am going to look at adding a new IP tables rule. So we're going to do IP tables-I. So we're going to insert a new rule, and I'm going to do -I input for the input chain, -P to specify TCP, that's the protocol, and then the destination port. So this is a destination port of the packet. So a packet is coming into our machine, and we are looking for the destination of that packet. If it's trying to get to port 80, that is our web server, what we will want to do is drop it. So if I do this, and then I just go and confirm, did we successfully add that rule? You can see here, we now have a rule, drop TCP traffic from anywhere, going to anywhere on the HTTP port. So if I go back to my web server over here, and then I try to just click on Etsy, it's not going to load. And if we run our Nmap scan again, we've got this filtered on port 80. So we went from open to filtered. It's not there. All right. So I'm going to actually show this in Wireshark. I think that'll be interesting to see. You can actually see what will happen. So let me go and add a filter. TCP.port equals 80. And then we're going to start listening on ETH0. All right, TCP port 80. Let's try to make a connection here. I don't know if I'm listening on the right interface. I might need to go and double check that. Yeah, I'm probably not on the right interface. Or am I? Just go to google.com. All right, so if I try to go to google.com, you can see all that traffic. TCP port equals 80. And then we also want to check for ip.adder equals 192.168. All right, so let's do a good old-fashioned wget on the IP address. All right, so we've got all of this traffic here. What we can see is our connection. I'm going to stop it now, actually. We can see our connection here. This is us on the... Hold on a second here. What is this IP address? This is not my IP address. We got to do another filter, I think. We're sharing, I've got the IP address shared between the host and the client. So I'm actually scanning myself. All right. So I think the source and the dest will have to be the same. So ipadder source, IP source, and IP dest have to be the same. I've made this too complicated now. All right. Well, I can see them right here. We've got these packets that are being dropped. That's the color that we have with the black. If I look into this, you can see that we make a request over TCP to connect to port 80. And then we make another request and we never get a response back. Now what I'm going to do is delete that rule. So iptables -d input 1. So now that rule is gone. And so if I restart my packet capture, and then I do my wget command again, bring that to the foreground. Man, Wireshark is not happy with me today. Give me your packets here. All right. Clearly I have the wrong interface or something going on here with Wireshark. So let's move on then. But you can see that this is how we are able to block and unblock the traffic on port 80. Let's move on to being able to only allow specific ports, because what we've done is we said we're going to allow everything except port 80. We're going to block port 80. And I actually want to go and do the reverse. Maybe I want to only allow port 80 and block everything else. So to do that, let's start by taking a look at our IP tables again. They're empty. They are flushed. And we're going to allow a connection here to port 22. So I'm going to show you what happens if you do not properly set up your IP table rules over SSH. And the defaults are going to matter a lot. So what I'm doing right now is I am allowing port 22, which will allow me to connect via SSH to port 22. So let's try that out right now. If I do ifconfig 0, and we just give ourselves a good old SSH 192.168.29.129. We're being asked for a password. All right, we're logged in right now into our machine via SSH. So what I'm going to do is set the default policy to drop everything on the input chain. This is going to be very bad for me. And there's a good reason why. So let me run this first and let you see what happens. I hit enter. And I don't know if you can hear me typing. My SSH session here is frozen. It's not working. But the machine is not frozen. So if I go back here to my command line, which is local, my local command line is working. It's only my remote SSH connection that is not working. And if you're wondering why this is the case, it's because SSH is a two-way protocol. TCP is a two-way protocol. And so when we added this rule to allow incoming connections to port 22, what we forgot is to make sure that not only are we, when we establish our TCP connection, the client is connecting to us on port 22, and we are connecting back to the client on some high number ephemeral port. And it's only when we establish both connections where we're able to communicate with each other. And what has happened here is we are blocking our own our own connection that we are requesting back to the client. So I don't know which port we connected on. I think if I run netstat, I can probably figure that out. So netstat, here's our connection. We are connecting port 22 on this high number port 57596. And so the connection back to our client on 57596 is being blocked. And so we actually kicking out on our own connection. What we need to do is tell IP tables to allow any traffic that has an established state on the TCP connection or a related state on the TCP connection, because if we don't, it will prevent the TCP handshake from completing. And that's what this additional line here is: IP tables -I input, and then this is the connection track, and then we're allowing any states that are established, and I would also say related states as well is probably a good policy. So what I'll do now is I'll just add that IP tables -I input -m contract.ct state, and then we've got established. Then I'll do related as well, -p input drop. Sorry, my brain skipped ahead. No, not -p, -j accept. All right, so now if we look at our IP tables, we can see that we are also accepting any connections that are related to or are from established connections. And if we are lucky enough, our connection has not timed out. Our connection has timed out. It's dead. So let me then try to establish another SSH connection, and hopefully this will work out a little bit better for me. 192.168.29.129. Enter, and there we go again. We now have our SSH connection back because we're allowing that traffic to come back. Other ways that this can go wrong. If you, so let me look at the IP table rules again. I'm going to default the policy back to, I'm going to default the policy back to be accept. And then I'm going to flush the chain. So now we're back to accepting everything. And what I will do is show you what happens if you have an SSH connection. You have an SSH connection here. Again, I'm on the right side. Let me minimize this to reduce confusion. All right, that just opened more tabs. Let me clear this out. So on the right side, we have an SSH connection, and we can look at our IP tables, and we have default policy accept. I am remotely connected into this machine via SSH. So I like if I look at netstat, like this is my connection right here. Established connection on port 22 right here. So I can see I have an active connection right here. If I go and added a default policy to drop, I immediately lose my connection. I can't type anymore. And so you, again, this is why you have to be very, very careful when you're remotely administering a device and updating the IP tables, because it's very, very, very possible that you accidentally kill your own connection and lock yourself out. So just be very cautious of that. I've got these little warnings here. Beware, IP tables doesn't save on restart by default. You have to take some extra steps to make it save. Flushing rules when the default is to drop, you lose your connections there, or accidentally deleting a rule that drops your existing connection. We saw that today. So there are a lot of ways for you to accidentally mess yourself up with IP tables when you're doing remote administration. I would avoid doing any remote administration on IP tables if possible, because there's just so many things that can go wrong. But I hope that was informative. You definitely got to see a lot of examples of what can go wrong with IP tables, trying to debug different things, trying to figure out why things don't work, trying to use Wireshark to pick up our packets. Pro tip on that one is that if you are running this entirely locally, it might get complicated trying to figure out which interface you need to listen to. But those are the basics of IP tables. Just keep in mind that firewalls are not a magic silver bullet. They're literally just saying what connections are and are not allowed. At the end of the day, if I have a vulnerable web server or I have a vulnerable HTTP server, if those get compromised, firewalls are going to be limited in helping me out over there. There's some things that they can do, but at the end of the day, if someone's able to get command execution through an exploit, it's pretty much game over. But thank you once again, and best of luck in the NCL season. I also will go through and answer any questions that you all have in the chat right now that I have not had the opportunity to answer. So we've got a question from Francois. Why are there 2 active SSH connections? 2 possibilities. Well, okay, narrowed it down to 1 possibility. I have 2 tabs open Both of these are SSH connections, and they're both frozen. So they're established connections, but because we dropped some packets, I've kind of lost my ability to connect to them, and they're still stuck in the open state because the TCP connection has not yet timed out. All right, Matthew is asking if you have a certain set of rules, and you don't want, if you have a set of rules that you don't want to run permanent, is there a way to save the configured set of rules to a text file? So yes, you can definitely save the rules to a text file. I know that there are ways to save your rules into a text file and then load it in automatically on boot. Let me just go and, save iptables rules between reboots. Do I still have my, yeah, I still have my default to drop. All right, default to accept. I'm not allowing myself to go to the internet. All right. You can go online and you can figure out how to do this really easily. There's apparently a package that you can install to set that up. A very, very low-tech way to do this: take all of your iptables commands, save them in a shell script, and then just run that shell script every time you want to use those rules again. All right, other questions from the chat. What is better between iptables and nftables? I have to admit, I'm not very familiar with nftables, so I'd appreciate if anyone in the chat has any thoughts and can weigh in on that. SK is asking, why use iptables instead of UFW? It comes down to personal preference. I believe UFW is is the easier interface to use. I've just learned iptables first, and it is typically installed on more machines than iptables. So that could be, than UFW. So that could be a reason to learn iptables over UFW. Definitely no harm in learning both. And yeah, I don't know if there's like a good reason to specifically use one over the other. UFW is generally easier, but iptables is probably going to be accessible on more machines than UFW, especially older machines that might not have UFW. Blake is asking, do you need to be running as the root user to use netstat? I don't believe that you do to just run netstat generally, but if you want to, I believe like certain ports might be privileged, and so you might need to be root. Let's see, do I have a Kali? I can check to see if I have a Kali user on here. If anyone from the chat has any ideas as well, please chime in. All right, well, I can confirm you can run netstat without being a root user. However, to run iptables, you do need to be a root user. So netstat, you don't need to be root. iptables, you do. Daniel asked, is iptables something specific for Linux? Is it a tool that can just be installed or that comes with the operating system? So iptables is a Linux program. I don't know if there's if someone has made an equivalent on Windows or on other Unix systems and just called it iptables. That could be possible as well. It is often pre-installed on most Linux-based operating systems. If not, you can actually install it through some sort of package manager. I can actually show you the Docker file that I set up here for the demo, I literally just do apt-get install iptables. So yeah, you can install it very easily with Package Manager. All right, that looks like all of the questions from the chat. Thank you all again for joining the live stream. Really appreciate having you ask your questions, and I hope you find this to be a valuable experience. We've got the NCL games coming up in a couple of weeks here. So right now we're at the beginning of March, if you're watching this live, and the NCL games are going to start happening at the end of March and going into April. It's still time to register. So if you or your friends are not yet registered for this season of NCL, go and check out the site, get registered, and start practicing more of these cybersecurity skills. This is not something that we have covered within the gym, but there are plenty of other cybersecurity challenges that we have available in our practice environment. And if you've got any suggestions and ideas for future episodes, what topics you want to learn, please ask them in the chat. Happy to go through and take your suggestions for future episodes. So thanks once again for joining us, and happy hacking. Take care, everyone.